Hello, I'm Professor von Schmohawk, and welcome to YU. In the last lecture, we introduced functions whose graphs in the Cartesian plane are lines passing through the origin. These are called linear functions, and can be represented by the linear equation y equals mx, where m is a constant whose value can be any real number, positive, negative, or zero. The slope of a line described by this equation is determined by the value of m. Depending upon m, the slope can be positive, negative, or zero. However, all graphs described by equations of this form are lines which pass through the origin. In this lecture, we will introduce linear functions whose graphs do not pass through the origin. These functions are sometimes called affine functions. The equation y equals x is a simple linear equation describing a line passing through the origin. Every point on this line has a y-coordinate whose value is equal to its x-coordinate. Now, if instead of equating y to x, we equate y to x plus 1, every point's y-coordinate will be 1 greater than before. Every point on this line has a y-coordinate whose value is 1 greater than the value of its x-coordinate. This equation describes the same line as before, but the entire line is 1 unit higher on the Cartesian plane. Likewise, the equation y equals x plus 2 describes a line 2 units higher. Or the equation y equals x minus 2 describes a line 2 units lower. In general, adding any real number b to the right side of this equation will shift the graph up or down by b units. This is true for other linear equations as well. For example, if we start with the equation y equals 2x and add 3 to the right side of the equation, the graph will be shifted up by 3 units. Once again, this is because the y-coordinate of every point on the graph is 3 units greater than if we had not added 3 to the right side of the equation. For this same reason, taking any linear equation of the form y equals mx and adding a constant b to the right side shifts the graph vertically by b units. The graph is shifted up if b is positive, or down if b is negative. This shifting of the graph is referred to as a translation. We say that the graph has been translated vertically by b units. The value of b determines the point at which the graph crosses the y-axis. This point is called the y-intercept. The y-intercept has coordinates 0, b. The first coordinate of the y-intercept is always 0, because every point on the y-axis has an x-coordinate of 0. Since we know that x is 0, we can find the y-coordinate by making the value of x 0 in the equation. This makes the first term in the equation m times 0, which is just 0. So the first term goes away, leaving us with the equation y equals b. Therefore, when x is 0, y must equal b. This tells us that the graph of any equation of the form y equals mx plus b always has a y-intercept with the coordinates 0, b. Because the constants m and b determine the slope and y-intercept, this form of the equation of a line is called the slope-intercept form. And any non-vertical line can be described by this equation. By adjusting the values of the constants m and b, we can orient the line in any way that we like. The value of b determines the line's vertical position, and the value of m determines the line's slope. Together, these two constants determine the orientation of any non-vertical line in the Cartesian plane. In the next lecture, we will show how to calculate the value of a line slope, m.